Hi, my name's Kagen Wittbold. I'm a customer success manager with Tractian. I'm also a Cat2 vibration analyst, and what we're doing today is going through some example insights of real-world customers showing where Tractian was able to prevent unforeseen downtime and prevent any unforeseen maintenance events. Today we're going through an example of bearing wear with a customer who makes truck wheels out of Erie, Pennsylvania. What we identified was a potential bearing wear problem with the compressor screw from this manufacturer. And what we identified initially was some BPFI, which we'll get into here in a moment, which is a type of bearing defect that was precipitating in this equipment and is actually still ongoing. So if we open up our analytics tab and we step into the FFT or the spectrum for this piece of equipment, one thing we're concerned with is looking at acceleration envelope spectrums of this asset, right? We're looking at bearing wear, so we're thinking high frequency. This is where we'll find these problems. So I want to go to the acceleration envelope, and here I want to reset my zoom, understand what's going on with the data, and then I want to zoom back in a little bit back here. And so we have these fault frequencies that show failure modes of bearings over here on the right. And you'll notice they're BPFI, BSF, BPFO, and FTF. BPFI corresponds to ball pass frequency inner, which is an inner race defect of a bearing. BSF, which is a ball spin frequency, meaning that the balls are spinning within the race of a bearing. BPFO, meaning that there's an outer race defect with a bearing. And FTF, which is fundamental train frequency. Fundamental train frequency is the frequency that shows when the cage that holds the balls within a bearing together is starting to fail. And each one of these, if I click one, they correspond with a different failure mode. Something that's important to understand here is that this asset runs on a VFD. And Tractian is accustomed to this, and we can interpret this data no problem. We just need to set the RPM for what this asset was running at the time. And working with the vendor, and during our weekly calls, this is something that we talk about. And so we did some investigation to understand during this insight, this asset was running around 900 RPM when we issued the insight. And so now when I click on these individual fault frequencies on the right, you'll notice that they potentially correspond with a peak. And if they do, like in this case where BPFI corresponds dead on with this peak, we know that we have a potential bearing problem with our asset, right? In this case, an inner race defect. And how we can verify this is if I reset the zoom one more time and kill all of these other fault frequencies, right? In this case, I want to only see BPFI. I can hit the multiples of this to show, wow, we have multiple harmonics of this BPFI. And what does harmonics mean? Harmonics would mean that if I have a spall or a defect on the bottom of my bearing on the inner race, right, an inner race defect, every time that shaft comes around, it's going to go ting, ting, ting. It's going to make an impact every time it goes around its rotation. And that's what's shown here with each one of these peaks on this graph, showing that we are having some harmonics, this bearing issue is starting to get worse. And you'll notice that this asset is actually, on its insight, is actually still in inspection. This is because this asset has been put on a watch list for us. This is something that Tractian keeps internally that we work with the vendor or with the customer on to make sure if an issue is getting worse, that we are constantly aware of its severity. And part of what my job is to go through that data and make sure that that issue is not getting worse. And if it is, to let the customer know so we know when and how the best time to take action is.